Hello everyone, welcome back to Open Source Summit Japan 2021, Day 2. We hope you had a great day yesterday and thank you to everyone for rejoining us. We have an exciting keynote lineup today, beginning with our first speaker, Dr. Audrey Lee. Dr. Audrey Lee is Senior Director of Energy Strategy at Microsoft, where she works at the intersection of policy, technology, and the commercial opportunities. She also serves on the board of ArcLight Clean, Transition 2, and Readaptive Inc. Between 2020 and 2021, she also serves as an advisor to LF Energy, which is one of the Linux Foundation project. Today, she will be talking about the grid decarbonization and how it affects to us all. So please welcome Dr. Lee.
Thank you so much. And thank you for this opportunity to speak at Open Source Summit Japan. I'm Audrey Lee, and I lead energy strategy on Microsoft's data center energy and sustainability team. Microsoft is a platinum member of the Linux Foundation and a member of Linux Foundation Energy. And I serve on the governing board of LF Energy as a representative of the general members. Today, I wanted to share with you our vision and commitments towards electricity grid decarbonization, and I'll provide some background on Microsoft's sustainability commitments and achievements, and then talk about our work on data center sustainability and how we are working to decarbonize our own electricity consumption and working to fulfill our vision of decarbonizing the entire electricity grid. One of the reasons why I joined Microsoft was the implications of Microsoft's mission statement. So our mission is to empower every person and organization on the planet to achieve more. And as our CEO has said, it's an enduring mission statement and it drives everything that we do at Microsoft. So achieving more means to power economic growth in a way that's inclusive, that builds trust, and creates a more sustainable future. And this empowerment by Microsoft represents to me a scalable way to support decarbonization across all industries of our economy by supporting technology innovation that we need. And I see Linux Foundation and open source playing a similar role in supporting decarbonization across multiple industries. At Microsoft, we started our sustainability journey over a decade ago, so it's not new for us. We've landed important work ever since we set our first carbon emission reduction goal back in 2009, and we've made steady progress. We realized that given the size of this planetary challenge, we needed to up our ambition. And so last year in 2020, we made significant commitments to guide our environmental sustainability work over the next decade and beyond, because we know that by 2030, society must be well on our way to mitigating and adapting to rapidly changing climates, and reducing the amount of waste we generate, ensuring resilient water supplies, and reversing the ongoing and catastrophic degradation of our ecosystems. Specifically to energy and carbon, we've committed to operating with 100% renewable energy by 2025. We've committed to becoming carbon negative across not only scope 1 and 2, but scope 1, 2, and 3 emissions by 2030. And we've committed to removing all of our historic emissions by 2050. And I'll talk more about specific electricity and data center commitments later in this presentation, like eliminating diesel from our data center backup generators, and 100% of our electricity 100% of the time coming from zero carbon resources. So as a reminder, greenhouse gas emissions are categorized as scope 1, 2, or 3. Scope 1 emissions are direct emissions created by a company's operations. Scope 2 emissions are indirect emissions, for example, from electricity use. And then scope 3 emissions are indirect emissions from the whole value chain. So the majority of our emissions are from scope 2 and scope 3 emissions. And this is where we are focused on decarbonizing. And specifically, I'll point out for scope 3, 2 areas where a large proportion of our emissions come from. And those are purchased goods and purchased goods and services. And so these are things that we need to run our business. For example, our data centers, the servers that we purchase. And the other is the use of sold products. And so, for example, we include in our scope 3 emissions the electricity that our customers use to play our devices like Xbox. And we're working hard to reduce those Scope 3 emissions across our supply chain and for our customers. When we made our commitment to be carbon neutral back in 2012, we levied an internal carbon tax across our business to enable us to meet that goal, to help us fuel innovation and really help drive better behavior across the business. In 2019, we increased that tax to $15 a metric ton. And in 2020, we announced our intent to expand that carbon tax to cover all of our supply chain, not just our internal businesses. And that's what's considered Scope 3 emissions for our supply chain. We track carbon emissions from all scopes and charge each business unit at Microsoft a carbon tax based on their portion of emissions. And then we use those funds to purchase renewable electricity to support things like carbon reduction and carbon removal, some of our water, waste, and climate resilience programs, as well as our AI for Earth program. And so for us, this carbon tax is a really effective way to help us monitor and forecast our emissions over time, which is really helpful for reporting. And we understand that not every company can institute a carbon tax, but we think it's important to talk about because even just the process of tracking, monitoring, and modeling carbon emissions can help drive operational innovation across multiple industries. We are also really committed to working with our partners throughout our supply chain to meet social and environmental accountability standards. And so last year in 2020, our top suppliers reduced their collective carbon footprint by 21 million metric tons. And our devices team built an audit management system using Microsoft Power BI to embed compliance and sustainability into our businesses. So now we can track performance and enable continuous supply chain improvements by tracking supplier maturity and social and environmental accountability. And then last year in 2020, we updated our supplier code of conduct to require our suppliers to calculate and report their Scope 1, 2, and 3 greenhouse gas emissions data. And so this data will become an explicit aspect of our procurement processes for our supply chain, including informing buying decisions. And we'll continue to work with our suppliers to onboard them to our new approach and ensure compliance. Solidifying our commitment to invest in the future, we've also initiated a $1 billion climate innovation fund, which we will commit over 4 years to accelerate solutions to the world's climate objectives. And we're doing this because we realize that not every company has the ability to fund climate solutions, but we believe that those that can fund such investment should. And we want to help Microsoft and the world reach net zero emissions through new technology innovation. And so the Climate Innovation Fund at Microsoft has a few objectives, and those are to innovate and accelerate technologies across carbon, waste, water, and ecosystems. And these are aligned with our 2030 climate goals. We're prioritizing funding for investments that, one, provide measurable climate impact. They bring additional capital to underfunded markets. And they also ensure developing economies and underserved communities benefit from climate solutions. And lastly, that they align to Microsoft's core business and that of our customers. And so we're investing directly in companies, funds, and projects to support existing technologies that need capital to scale in new and niche climate solutions. And so focus areas include direct carbon removal, digital optimization, advanced energy systems, industrial materials, as well as sustainable agriculture, forest, and carbon monitoring solutions. So I provided some background on Microsoft's sustainability commitments and actions, but now I want to tell you more about Microsoft Cloud and our data centers, and that's the area where I work. Today, we operate more than 220 data centers connected by more than 1 million miles of fiber. And the cloud energy team that I'm a part of is responsible for power infrastructure. So how do we physically get transmission interconnected electricity to our large data centers, power purchasing of renewable energy, the use of distributed energy resources, as well as regulatory policy and advocacy. So I'm in the Cloud Operations and Innovation Group at Microsoft, and a central goal for us is to build and maintain a reliable and sustainable cloud. And I think it puts us in a really unique position because we have 3 very different perspectives. And so Microsoft's cloud platform is a consumer of energy in order to serve as a platform for customers whose carbon footprint is in turn reduced as we reduce our carbon footprint. We're also a large customer with a stable, high-value load to the electricity system, and we work with those electricity providers to ensure reliability for that load for our customers using our cloud. Second, we're also a collaborator in clean energy and grid infrastructure. So we're dedicated to procuring 100% renewable electricity for our data centers and supporting an electricity grid that provides reliable, clean energy to all customers. And then lastly, we're an innovator in energy technologies. After all, we are a technology company. Our innovations improve grid reliability and energy efficiency through technologies that help manage grid power loads, as well as optimize power transmission and distribution. And in addition, we're developing technologies to better manage other environmental resources such as water. Our approach to decarbonization is threefold. First, that it must be rapid. We must deploy zero carbon resources with currently available technologies like solar, wind, batteries as quickly as possible. And we're doing so through our 100% renewables goal by 2025. Second, what's important is our approach must be complete. Current technologies are not enough, and we have to invest in advanced technology, and we must invest in the infrastructure of the grid. And then most importantly, our approach also must be just. We must ensure that climate equity and community benefits and opportunities in the investment and deployment of decisions that we make. And we believe that this is a very unique platform for climate innovation for our contributions. So first, as a consumer, as a data center provider, Microsoft uses energy to enable customer innovation. As an industry, data centers are heading in the right direction towards improved energy efficiency. In fact, in a 2020 study, the IEA found that since 2010, over the past 10 years, data center energy use has remained constant, even as workloads increased 8 times and internet traffic increased 12 times over those 10 years. And so this International Energy Agency report provides a clear image of data center energy efficiency as companies like Microsoft help data become increasingly clean. Our customers, by moving to the Microsoft cloud from on-premises servers, can increase their energy efficiency and ensure that their cloud is powered by clean energy. And to meet our 100% renewable electricity by 2025 goal, in fiscal 2021, Microsoft signed 5.8 gigawatts of renewable energy across 10 countries. We were the top corporate off-taker in 2021, according to Bloomberg New Energy Finance. And this puts our total operating and contracted renewable energy projects at 7.8 gigawatts. But procuring renewable electricity on an annual and global basis is not enough. And that's why we announced earlier this year our 100-100-0 vision and commitment. Our vision is that on all the world's grids, 100% of the time are generated from zero carbon sources. Our commitment for ourselves is that by 2030, Microsoft will have 100% of our electricity consumption 100% of the time matched by zero carbon energy purchases. And we made this commitment because we learned in a pilot last year in November that we did with Vattenfall, Swedish energy company, large Swedish energy company. We announced with them the development of a first-of-a-kind solution to match renewable energy, not on an annual basis, but on an hourly basis. And this pilot program is currently running on both Vattenfall's and Microsoft's Stockholm headquarters in Sweden. So this product, which is available to all of Vattenfall's retail electricity customers, allows the user to see their real-time energy usage by renewable energy source on an hourly increments. From an accounting perspective, the reconciliation of energy consumption with, in Europe, guarantees of origin, or in the US, renewable energy credits, often occurs on an annual basis. And at the end of the year, corporations take their total number of renewable energy credits procured in a year, and they divide that by the number of megawatt hours consumed in a year. And so that annual measurement has served as a really convenient point of reference to communicate corporate social sustainability goals and accountability for renewable energy commitments. However, this system conceals a basic flaw in the system, because at any hour, a business doesn't know the source of the energy that they're actually consuming. And that energy may come from renewable sources, or it may be produced from fossil fuel. And so the current system has no way of matching the actual supply of renewable energy with demand for that energy on an hourly basis. And without that transparency of supply and demand, our market forces can't work to ensure that renewable energy demand is actually supplied from renewable energy sources. And so this platform provides that transparency to users so that they can understand their energy consumption on an hourly basis and allows them to procure renewable energy credits from generation sources that ran during that hour. Through the solution, the Microsoft Sweden office building is powered by renewable energy throughout the procurement of renewable energy credits, not just on a monthly or yearly basis. And again, as you can see on the right, Microsoft plays a variety of roles. We're a developer of the tool, we're a user of a service, a consumer of electricity, but we're also advocating for more widespread publishing of more accurate carbon emissions rates. So here's a snapshot of the Microsoft Sweden office, where you can see hydro and wind generation being matched to consumption of that office on an hourly basis. And while hourly matching is really important, we also recognize that not all renewable megawatts are the same. Corporate procurement has historically focused on a megawatt hour to megawatt hour match on an energy basis. But we know that every megawatt hour of renewable energy has a different impact in terms of the actual tons of carbon offset. And really the end goal for us is reducing CO2 emissions and decarbonizing the grid. So how do we get from measuring megawatt hours to actually reducing CO2 emissions? And the problem is that corporate procurement can potentially invest in renewable energy in the wrong place at the wrong time. The graph on the right shows how the emission rate, the green line, varies over a 24-hour period, and it can vary over seasons as well, although it's not shown here. And here you can see that solar and wind generation together are highest when the grid emission rate is actually the lowest. And we would have far greater carbon reduction impact by generating clean energy like solar and wind during higher emissions rate periods in the evening and morning. So we want to translate megawatt hours into tons of carbon because decarbonization is the goal. And we want every dollar of corporate spend to reduce the maximum amount of carbon. So renewable energy is a means to the end, with the end goal being carbon reductions. And the emission rate or CO2 reduction impact corresponds to three factors, not just time, as I showed in the Sweden Vattenfall example, but also location and something called marginal impact. As I said, clean megawatt hours of energy can result in varied CO2 reduction outcomes. And it might be easier to see this challenge of estimating carbon impact as more multidimensional. So I had described the time axis and our commitment evolving from an annual basis to more granular timescales like hourly. But location is the second axis, where we're moving from global to more grid-specific boundaries. And then the third axis is where CO2 emissions are considered on an average basis, or whether the marginal impact is considered. And the marginal impact takes into consideration the actual physics of the grid, the actual power flow and impact of additional supply or demand. So no methodology is perfect, but in general, we're focused on moving to more granular measures as data becomes more available for us to make better investment decisions and deployment decisions to maximize our CO2 reductions. That third axis that compares average emissions to marginal emissions, combined with the location axis, is an area we've been studying and trying to learn more about. And so we've been working with a company called Resurety to look at locational marginal emissions, or LMEs. So the locational marginal emission measures the tons of carbon emissions displaced by one additional megawatt hour of clean energy injected to the grid at a specific location and a specific point in time. So our study with Resurety looked at the Texas ERCOT grid in the US. We calculated at each power system node. LMEs offer a similar level of specificity to what you commonly see as locational marginal prices that are used to calculate wholesale electricity prices. So it's sort of a sister factor with locational marginal prices. Locational marginal emissions assess the carbon emissions avoided by the injection of renewables into the grid at a specific location and moment. So said another way, they identify and quantify the marginal generators that would have been producing energy, but did not due to the activation of clean energy at those points. What type of fossil fuel generator did you avoid firing up because you injected renewable energy at a specific place and time? And the differences in locational marginal emissions value can be due to system characteristics like transmission congestion in specific locations. So you can see on the map the red circles of solar generation in West Texas on the left that have a very low locational marginal emissions value or small impact in CO2 reduction. And that's likely constrained by transmission congestion to transport that electricity to larger cities where most of the electricity demand is located. And so locational marginal emissions offer a deeper level of insight for us into energy use because this metric actually assesses the carbon emissions from for the load at a particular location and moment. And this node-specific insight helps us deploy clean energy where it can be used most effectively to reduce carbon emission. It also has implications for carbon accounting and power grid design. So the result is that locational marginal emissions can be a force multiplier for our clean energy investments. Resurety found that in a 2-year analysis of renewable energy projects across Texas, that the LME-informed deployment of clean energy to the highest value renewable projects put in the right place and at the right time doubled the carbon impact as compared to the traditional approach of annual energy matching. So this gives us insight into whether the energy we are procuring over an hour is clean and what the carbon emissions impact is for our load. So when our data centers are using energy, we can track how much carbon we're emitting to get that energy at that location, and we can use that insight to make investment decisions. When we build a renewable project, we can ascertain how much carbon it would displace in the location and what's the delta. And ultimately, the goal is to eliminate the delta to become totally decarbonized. In the electricity decarbonization arena, we see really 2 parallel innovations, and they really need to come together. So I've talked about 24/7 hourly renewable energy matching. It's a means to means renewable energy credits and their attributes. And organizations like EnergyNet, the Danish transmission system operator, in Denmark, and MRETs in the US are working on this. And in parallel, science-based targets mean new CO2 metrics and offtake mechanisms. And as I mentioned, we've worked with Resurety here to determine locational marginal emission factors in the Texas ERCOT market. PJM in the US has started publishing locational marginal emissions in its market. And we're working with organizations like Watt Time and Electricity Map and TCR on this as well. But really, these innovations need to come together. And so the 3 big takeaways that I want to leave you with is that clean energy purchasing is helpful, and Microsoft can do a lot of that purchasing, but it's really no substitute for policy if we want to decarbonize the entire grid. So corporate power purchase agreements have totaled over 100 gigawatts globally, but most of them are concentrated in the US, and thousands of firms feature renewable energy purchasing or science-based targets. But power market design, utility practices, those should be used to amplify this progress. Second, new data tools improve corporate policy efforts to decarbonize. As I said before, clean megawatt hours, they're a means to an end, and that end really is how do we reduce CO2 emissions. So not all clean megawatt hours create the same outcomes on CO2. And so we need new data tools. We need this information to make the right decisions to reduce CO2 emissions. For example, like locational marginal emissions that link megawatt hours and translate them to actual CO2 emission outcomes. And then third, independent system operators, utilities, innovators are key to better CO2 reduction scoreboards. So renewable energy is largely built where it's convenient and where it's possible. But are we using all the data that we have and collecting more data to make sure that they're built where they're necessary to decarbonize our grid? Purchasing 100% clean energy is not the same as consuming 100% carbon-free energy. So how do we use data to make those linkages? And better CO2 reduction metrics matter for the power industry, for our innovation, and for our infrastructure investments. And I really see the collaboration through forums like Linux Foundation Energy with transmission system operators, distribution system operators, technology providers can really help us accelerate grid decarbonization, and really value the collaboration that I've seen in these forums and being able to work with all these stakeholders. So thank you. Really appreciate the time. Please feel free to reach out if you have any questions. Would love to discuss this further with more stakeholders in this area. Thank you.
Thank you very much, Dr. Lee. Our next speaker is Miguel Ojeda, a software engineer that maintains the Rust for Linux effort. He also participates in the ISO-C committee with an interest in UB and memory safety topics. Previously, he was a staff member at CERN in the Beams department and fellow in the physics department. Today, he will discuss Rust in the Linux ecosystem. So please welcome Miguel Ojeda.
Hello everyone, thank you for inviting me to the Open Source Summit Japan. As you know, we are celebrating the 30th anniversary of Linux. Systems based on Linux have seen an increased use over the last decades. Linux is deployed everywhere nowadays. There are billions of devices out there, from smartphones to cars, servers, etc. We have even seen Linux running on Mars. And it's also roughly the 30th anniversary of the C standard. The C programming language is used by all kinds of Linux software, especially for low-level applications or for applications that require high performance. And this combination of Linux and C has been a bit like a love story with ups and downs, because on one hand, this combination is used and it has been successfully used by lots of companies and entities. But on the other hand, C, C++, and other programming languages, system programming languages, suffer from memory and safety. Memory and safety is the reason behind 70% of the vulnerabilities discovered in C and C++ projects. This 70% figure comes from several reports from security researchers and from companies, and I will show you a few of them in the next slide. Now, it is important to discuss that memory safety issues have a real cost associated with them. It affects internet-facing devices and code, because memory safety issues may be the reason behind some of the vulnerabilities. But it's also a problem for devices or code that handles only trusted data. For example, if you are in a controlled environment, you may have less reliability in your system because you may be suffering from memory safety issues that trigger, for example, a crash. Or you may suffer from data correctness issues if you have some corruption going on. Even things like video games suffer from memory safety issues if they are coded in C or C++, for example. But in general, it's an economic loss for everyone involved. Now, another key thing to discuss is that in projects that use C and C++ and similar languages, normally we employ tooling like static analyzers or fuzzers to reduce the number of vulnerabilities, to catch them early on, to discover them early on. But memory safety issues, even if you do everything by the book, even if you hire security engineers, even if you are running static analyzers, fuzzers, etc., all day long, like this project from Google Zero shows, which was released just a couple of weeks ago, even if you do everything right, eventually you are going to be hit by some memory safety issue. In particular, the last quote here in this slide is quite telling, because it says, even extremely well-maintained C and C++ code can have fatal trivial mistakes. And actually, it's not just that, it's that these issues may go unnoticed for a long time. Now, what do we need? What we need, or what we want, is a language that ticks several boxes, all of these ones. The first one is that we need a system programming language. That is one language that can be used for the same things that we have been using C for. For example, operating systems, embedded applications, etc. We also want that the language is memory safe. That means avoiding the memory safety issues that we have discussed. We need that it's mature as well, ready for production, that has been used by different projects. We also need that it's backed by the industry. That means that big companies support the language. Not only that, there are many. We need that there are many engineers interested in working with the technology. And this is where Rust comes in. Rust is a language that ticks all those boxes. So it is a memory-safe language, it's a system programming language, is backed by the industry, and is mature enough. Now, what does Rust offer? Rust aims to eliminate several classes of bugs. For example, use after-free, out-of-bound accesses, and initialize memory reads, etc. Now, a particularly interesting element of this list is the last one in the slide, data races. because Rust aims to guarantee there are no data races in your program. However, please note that this guarantee does not cover general race conditions. In general, we can say that Rust promises no undefined behavior. Undefined behavior is a similar concept in Rust as in C, as in the C programming language, and can be understood as erroneous or incorrect behavior. And it includes memory safety issues. However, conditions apply to this promise. It's a conditional promise. Because Rust is a system programming language, it still allows operations that can potentially trigger undefined behavior, like, for example, dereferencing a row pointer. These operations, however, have to be done in unsafe code, in what is called unsafe code. And the promise that Rust does, the conditional promise, is that as long as this unsafe code in a program is correct, then Rust promises there is no undefined behavior elsewhere in what is called safe code. Now, even though this promise is conditional to that, I think that it's a fundamental improvement with respect to C and similar languages. Now, to be completely clear, and in particular because this conference runs with the automotive Linux 1, I want to emphasize that safety in Rust is only about no undefined behavior. And in particular is not the same as safety as is understood in safety critical systems. Functional safety is about the process, the requirements, the traceability, testing, etc. But nevertheless, the decreased chance of memory safety bugs may be interesting, of course, for critical systems development. So what else Rust offers? In the language, there are things like a stricter type system compared to C. There are some types, pattern matching, generics, powerful macros, etc. All these features are, in my opinion, well designed and they work quite well together. In the standard library, we have things like integer arithmetic primitives that allow you to precisely specify the flow behavior you need, for example, saturating or wrapping. There are also vocabulary types, that is, types that are useful for most projects. For instance, result for error handling. In the tooling side, tooling is quite mature. There is static analyzers already. We have a linter. There is a quite nice build system, a code formatter, and even tools like UVSAN from GCC and Clang for the unsafe code that you may have in a program. And of course, GDB, Valgrind, etc., third-party tools work with Rust. Now, I mentioned before that there is industry backing of Rust, and here I saw the founding members of the Rust Foundation. There are others that also are supporting Rust, including, for example, security researchers that recommend it and engineers. Basically, the summary is that we have seen that Rust is a good candidate for new development of system programming software. Because it provides memory safety, it has learned from decades of experience of C and C++, from functional programming as well, is mature, and as we just saw, is backed by relevant companies in the industry. And for those reasons, I believe it's a good time to take a look into these kind of languages, for instance Rust, for all kinds of software that we previously wrote in C or C++. Of course, the kernel is a good example of software that is written in C, and this is in fact the origin of the Rust for Linux project. The Rust for Linux project aims to introduce Rust as the second language in the kernel, and of course, introducing any second language has a cost for any project, especially if it is a project as big or as complex as the kernel, or for projects that have hundreds or thousands of contributors. But we believe is worth the effort in the long run for the following reasons. The first one is that we think we will have a decreased chance of memory safety bugs. And I say chance here because the Rust guarantee that we saw is conditional. We also hope that it decreases logic bugs compared to C, thanks to other properties of the Rust language, for example, the stricter type system that we saw. Also, writing drivers or modules in Rust should be easier. Kernel developers can focus more on the logic and not so much on the memory safety issue that they have to care about when writing C. And similarly, for kernel maintainers, reviewing drivers should be easier as long as there is not so much unsafe code that they have to review. And finally, and critically, refactoring code should be less risky, at least in terms of undefined behavior. The reason is that when code is written or reviewed the first time, it may be correct, but then each change after that has a risk. And the safe-unsafe split in Rust should reduce the number of memory safety bugs, even across refactors. And there are quite a lot of refactors of internal APIs, for example, in the kernel. Now, it is natural to ask how all this works. In the kernel, there are C APIs that provide facilities for drivers and other modules. These APIs or subsystems or libraries are called unsafe in Rust terms because there are safety preconditions of contract that the clients have to be aware of. The clients, I mean drivers or other modules. What we do in Rust for Linux is to provide safe abstractions for those safe APIs. These safe abstractions are responsible for exposing a safe API to drivers and modules, which means that the drivers that use these safe APIs or these safe abstractions don't need to worry about introducing memory safety issues, as long as, of course, the abstractions themselves are correct. Normally, abstractions use some degree of unsafe code. The forbidden line that you see in the bottom shows that eventually we want to forbid all direct calls to the safe APIs from the Rust drivers. So in a sense, and this is what the title of the slide refers to, what we are doing is encapsulating the unsafety of the C APIs into safe APIs. Another common question we get is the goal to rewrite the kernel? As you see here, the answer is no, because our aim is to be able to write safe drivers. So what we are doing is adding code. We are adding code for the new drivers and we are adding code for the safe abstractions, but we are not rewriting existing C code. We are just wrapping it. Of course, in the future, kernel maintainers and developers may decide that they want to write a new entire subsystem in Rust, and that will bring other benefits. And even longer in the future, somebody may want to rewrite a core part of the kernel in Rust, but that would require making Rust mandatory, which is not the case now. We don't think it will be the case for a long time, because first we will need to prove that Rust is useful in the kernel. Now, to give you a bit of a summary on the state of the project, the project is to be considered experimental, but it is useful for testing the waters. This means that kernel developers, maintainers, companies can start writing their abstractions in Rust, as well as their drivers and modules. We have a couple of example modules that we submitted in the last patch series. One is a GPIO driver, and the other is an Android binder port to Rust. And for the next steps, we are working on improving the infrastructure. This means, for example, having a full test framework that provides basically the same functionality that KeyUnit and KeySelf-test do for C. We are working also with upstream Rust to submit some changes to the standard library that we need, as well as other feature requests that we have for different parts of the Rust toolchain. We are also working on removing some restrictions that the Rust support has, and on adding more architecture as well. And of course, on the side of the Rust code, we are working on providing more abstractions and general facilities that Rust drivers will need. And we are also working on an example NVMe driver. Now I want to focus a bit on the industry support. Before we saw the support for Rust, the language itself. And now I want to show some statements from companies that have an interest or support the Rust for Linux effort itself. The first one is from Google. Google directly supports the effort. We have also another one from ARM. ARM is supporting Rust and is also interested in Rust for Linux. Microsoft is interested in perhaps submitting some Hyper-V drivers written in Rust to the kernel. And we also have Red Hat that is interested in using Rust for kernel work. Finally, I want to highlight the Proximo project. The Proximo project from the Internet Security Research Group is working on bringing memory safety to the Internet's most critical infrastructure, and they chose Rust for Linux as one of their key efforts. And I want to thank them for that selection. If you want to know more, please take a look at the next keynote from Josh. And with that, thank you for joining me today. I will be available to answer some questions in the platform. And that's it. Bye.
Thank you, Miguel. Our next speaker is Josh Oss, Executive Director and co-founder of the Internet Security Research Group, ISRG. ISRG is the nonprofit entity behind Let's Encrypt, the world's largest certificate authority, helping to secure more than 250 million websites. He also has led ISRG's new profit, Proximo, which focuses on bringing memory-safe code to security-sensitive software. Today, Josh will discuss memory safety for critical digital infrastructure. Please welcome Josh Oss.
Thank you. I'm really glad to be here. So I'm with the Internet Security Research Group. We're a nonprofit that was founded in 2013, and we think of ourselves as a home for public benefit digital infrastructure projects. And what I mean by that is we like to run infrastructure for the public and invest in the software and services that help run public infrastructure. We're probably best known for our certificate authority called Let's Encrypt. Our certificate authority is free, automated, and open. We serve more than 260 million websites, including many millions of websites here in Japan. And we're issuing about 2.5 million certificates daily. The project I'm going to talk to you about today is called Proximo. This project is newer, launched in October of 2020. And this project is all about moving security-sensitive software to memory-safe code. So here's the problem that we're looking to work on. A lack of memory safety is a really serious and persistent threat to internet infrastructure. The problem is mainly with C and C++ code. New memory safety vulnerabilities in widely used software come up every day. And again, this is almost always in C and C++ code, a little bit of assembly as well. So if we think about the software stack that we use on the internet today, at the top we have web browsers and at the bottom we have kernels. It's really quite unsafe in memory safe terms. So web browsers are huge piles of C++ and C, the servers, the proxies, business logic, cryptography, image processing, and the kernels. They're all C and C++. So from top to bottom, just about every deployment stack out there has many millions of lines of code that we know to be unsafe because it's written in languages that regularly suffer from these vulnerabilities. I don't think it's exaggerating too much to say that the problem is out of control, right? 90% of vulnerabilities in Android are due to memory safety. About 70% of all vulnerabilities in Microsoft products over the last decade have been caused by a lack of memory safety. About 80% of vulnerabilities discovered to be exploited in the wild are also due to memory safety. So this is really pervasive. Nobody using C and C++ is immune from this. Even the best teams in the world have a hard time protecting themselves. So society pays the price for this every day. It has a real impact on people's lives. So there are a lot of privacy violations, identity theft, database breaches, huge financial losses, denial of public services from hospitals, power grids, and human rights impacts. So this is not just sort of an abstract computer industry problem. This has a real impact on people's lives every day. We have a lot of problems in the computing world that we're not quite sure how to solve. We don't really know what to do. They're really hard problems. This is not one of those problems. We know exactly how to solve memory safety. You replace the code that isn't memory safe with code that is. And that's a lot of work. I don't want to imply that it's easy, but we know exactly what we need to do, and we just need to do the work. We're in an industry where we have so much talent and so many resources that if we want to take on a problem like this, we can do it. I think we can make much of the internet software infrastructure memory safe over the next 5 to 10 years. I want to talk a little bit about fuzzing and static analysis efforts. So when you have teams working on C and C++, they'll often try to secure their code with fuzzing and static analysis. And that's a really important thing to do if you're working in C and C++. It can help find a lot of vulnerabilities before they become a real problem. It's not a complete solution, though, and it's not something that we can really rely on for the future. It introduces a lot of overhead, which makes things more difficult for teams. It's applied inconsistently, and again, ultimately, it doesn't solve the problem. Fuzzy and static analysis are definitely worth investing in, but that's not what ISRG and Proximo are focused on. We're looking at more complete long-term solutions and moving away from languages that are not memory safe. So I include this slide and the next one to try to make this more personal for everybody, right? So we've all got phones. These are all vulnerabilities that are relatively recent. They're all memory safety vulnerabilities in major mobile operating systems. That's in your pocket. My phone is a really central part of my life. It's the thing I depend on more than any other device. And these vulnerabilities put me and my data at risk, and that's true for everybody. When I get a software update for my phone and I look at the security contents, every single time it is a long list of memory safety vulnerabilities. And we know how to prevent all of this. So our memory safety project, Proximo, has two goals. We want to make the internet's most critical software memory safe, and we want to change the way that people think about memory safety. Our role is really comprised of these four components. So we want to build a strategy for how to move really important pieces of software to memory safe code. We want to facilitate and coordinate the engineering that needs to happen. We want to do the fundraising to raise funds to do the work. And we want to communicate about this work. So ISRG engineers are not the ones who are going to be able to do all this work. This is a huge amount of work, and it's going to involve engineers across the industry, at companies, volunteers, open source communities. We want to help figure out how that work can happen and facilitate making it happen. So when we talk about what software are we going to work on, we start by identifying risk. We start by looking for software that is very widely used, stuff that's on nearly every server or client. We look for things that are on a network boundary. We look for things performing critical functions. And we look for things that are written in languages that are not memory safe. So if something fits all of these four criteria, then it's something we're going to take a serious look at. Once we've identified risk, we look at identifying opportunity. So is this a library or a component that we can use across many different projects? Can we efficiently replace key components with existing memory safe libraries? Essentially, can we take advantage of the modular nature of a program? Are funders willing to fund? So do we have the resources to do the work? And are the maintainers of the software on board with what we're trying to do in a cooperative? So if you have a piece of software that's really high risk but doesn't have any of these sort of opportunity factors, then it can be harder to make the change. And that doesn't mean we're not going to try, but it does mean it's going to be harder, and we may prioritize projects where we have greater opportunity. So I'm going to talk a little bit more about modular improvement, because it's a huge part of the strategy that we have. So a lot of software, it would be pretty impractical to just start from scratch and say we're going to throw out the old C and C++ code, and we're going to start from scratch and build a replacement. That just does not make sense in a lot of cases. What we really try to do is find components that can be swapped out. So you can take, for example, a C-based TLS library, swap it out, and put in a Rust-based TLS library, or you can do that with an HTTP library or a text processing library. So that's a much more efficient way to start delivering, security improvements to an existing project. It also means that when we invest in those libraries that we swap in, those investments apply to multiple different software projects, and it's just a more effective investment for us. So modular improvement is really important. We also think it's really important to work with maintainers. So maintainers have valuable knowledge about how to ship memory safety updates to their existing users, and that to me is the biggest thing. So if we have to, build our own version of a piece of software and get people to switch from one piece of software to another, that is a really heavy cost. It's much more effective if we can just get the maintainers to ship improvements in the software so people get them when they do a software update. So they go from one version to a newer version and they're safer. We don't have to try to convince them to switch to a different piece of software. I also just think that it's the right thing to do to focus on maintainers. They put a lot of work into making software that's really important. And if we can work with them to make change, I think that is a much better thing to do than to try to, start a parallel track or some other piece of software. So building trust is really important. We're asking people to do a lot of work, and we recognize that we're asking people to do a lot of work. And I think it makes sense for them to understand why they should trust us. So some maintainers are understandably hesitant to make fundamental changes to how their project work, to learn a new language after working in the same language for 20 or 30 years. It's on us to make the case for that, and we'll do that by building up success stories. And when we go talk to maintainers, we hear their concerns, we can say, there are other maintainers who had these concerns. Why don't you take a look at this project and how things worked over there? Maybe you can talk to the maintainer. And we'll really try to build up trust by being able to point to our track record in the past. So these are our current projects. Rustls is a memory-safe TLS library that we're hoping will replace OpenSSL in a lot of applications. This is really important to us. A lot of applications use TLS, and you can make a big impact right away by swapping out OpenSSL or its equivalents for Rustls. So we're paying a lot of attention to what people need in order to make this work. We've invested in a really nice C API for Rustls so that the maintainers don't even have to learn Rust. They can just use the C API to access the Rust code from their existing C code. OpenSSL has a long history of vulnerabilities related to memory safety, so we think this is just a slam dunk investment for us. This just makes so much sense on every level. We're also investing in Apache HTTPD using Rustls. So Apache HTTPD has always done SSL and TLS through a module called mod.ssl, and that uses OpenSSL and other C-based code in the background. So we have a new module called mod.tls that uses Rustls for memory-safe TLS, and you can use that in Apache, and that is available today, and we're going to keep investing in that with the community. And our goal is to help the Apache HTTP community become more comfortable with components that are in memory-safe languages. If we can provide a really great experience with bringing Rust into the ecosystem through Rustls, maybe they'll be open to making other changes in HTTPD. So the Linux kernel is another really exciting one. I'm an ambitious person. I think it makes a lot of sense to take on all this work in our industry, but even I had some pause about the Linux kernel. When we started, it just seemed, almost insurmountable to bring memory safety into the Linux kernel. But Miguel Ojeda and Alex Gaynor and some others have done really great work making progress on this, and they are moving at a really rapid pace. So there's a patch set that's ready for the Linux kernel that just makes it easy for people to write, drivers in particular, in Rust. And it's just incredible. I shouldn't be at a loss for words in a talk, but I almost am. I really recommend looking up the work that they've done with the Rust for Linux project to bring Rust in the Linux kernel. That's going to make a huge difference. DNS is another one of those places. It's a really critical service that every device uses. Almost all the implementations are not memory safe. It's on a network edge. DNS is just ripe for attack. It's been attacked before. It's going to get attacked again. We need to bring DNS implementations to memory safe languages. So we're working with a number of different organizations on memory safe, high performance DNS resolvers. And we hope to announce more about that soon. NTP is in a really similar position as DNS. It's every device needs to know what time it is. Almost all the implementations are written in languages that are not memory safe. It's on a network edge. Every device, we need to do something with NTP now before it becomes a huge problem for us. So I'm really excited about all these projects. I want to note that up until recently, I don't think this stuff was possible. We've had memory-safe languages for a long time, but we haven't really had a good memory-safe systems language before Rust. The stakes are getting higher as more and more of our lives depend on software. So that's making it easier to make this argument. So I don't think that people who've been writing C and C++ for many, many years and building critical infrastructure on C++, I don't think they need to feel bad about what they've done. Obviously, they've provided a great service by writing software that's so important to us in the first place. But I think it is possible to do better now, and I think we need to start moving in that direction. So I mentioned before that we have sort of two goals, and I spent most of my talk here talking about how we can actually improve the critical software on the internet. But it's also important that we change the way people think about memory safety. And here's the example I like to use. If you ask an engineer today to deploy a reverse proxy, even a security-conscious engineer is probably going to reach for something like Nginx or Apache or something else that's essentially millions and millions of lines of C. That's really standard practice. At the same time, we have just mountains of evidence built up over decades that C is not a safe language to be processing data from the internet on, right? We know it's not safe. We have so many examples of that. But it's just standard practice to do today. And when you do that, you put millions of lines of C code on the edge of your network processing untrusted network data. That's where we are today. That's a normal thing to do today, and it's not considered to be irresponsible in any way, for the most part. That's got to change. My hope is that 10 or 20 years from now, people come to understand the risk better, and more importantly, we provide people with better options so that 10 or 20 years from now, when someone is asked to put, a reverse proxy into production, they wouldn't dream of putting something written in C on the edge of their network, because that would be seen as quite dangerous. That's where I think we need to go. We're not there today, but we're going to do our best to get there. So thanks so much for having me again. I want to thank a lot of our community members listed here. And I also want to thank a bunch of our sponsors who are listed, based in Japan, listed here on this slide. So thank you so much. Have a good day.
Thank you, Josh. Finally, our last keynote speaker today is Dr. Ibrahim Haddad, Executive Director of LFAI and Data, and maintainer of open source AI and data landscape. Throughout his career, he has held technology and portfolio management roles at Ericsson Research, the Open Source Development Labs, Motorola, Palm, Hewlett-Packard, and the Linux Foundation, and Samsung Research. He is joining us today to talk about accelerating innovation in open source AI and data. Please welcome Dr. Ibrahim Haddad.
Hello, everyone. Good morning, good afternoon. My name is Ibrahim Haddad. I am the Executive Director of the LFAI and Data Foundation, and I'm very happy today that you're able to attend my talk and hear me talk about the effort we're doing to accelerate development and innovation in the open source AI and data. To start off, Who is LFAI in data? We are an umbrella foundation within the Linux Foundation, focused on hosting critical projects in the open source AI and data domain, supporting the developers, supporting the organizations and the companies within these different projects, and driving forward innovation in this really critical technology sector. Our mission is to build and support this AI and data community and drive innovation in all of these subdomains of AI. That includes machine learning, deep learning, data, models, NLP, ethical AI, and many, many more. We enable collaboration, we enable best practices, and we support the actual development and the creation of many new opportunities for everyone involved in this process, whether it's technical projects, individuals, and organizations. If you look at our members today, we started with 9 members around 3 years ago. And today I'm happy to report we're over 50 active members in LFAI and data. These members cover different geographies from North America to Europe to Asia, and cover really key organizations that are actively contributing to these different technological projects in the open source AI and data ecosystem. As for projects, as of today, as I'm recording this message in early December, we host 35 technical projects. These 35 technical projects are divided into 3 categories. The first category is what you call graduated projects. We have 7 such projects. These are mature projects that have been tested and really deployed at very large scale. And then we have incubation projects. These are projects that are currently in quote unquote incubation, getting the support of the foundation. And our goal is to grow them within their specific category, to support their development community, and to enable easy adoption and integration between them and many other projects within the ecosystem. And the last row you see on the screen are 5 sandbox projects. These are kind of early projects. They have a great idea. They have initial proof of concept, and we're supporting them to grow them to become eligible for incubation. And then past incubation, they would move into graduation following a set criteria. So if you're a developer out there listening to my talk and you have an open source project that fits AI or the data domain, we're more than happy to talk to you and figure out ways to bring your project and help enable it as part of our efforts in LFAI and data. So who are hosting projects with us? As you see on the screen, we have a number of organizations that are hosting these 35 projects with us. I'm pretty sure you'll be able to identify all of these companies. They are top tech companies across the globe, from India to China to South Korea to Europe, many European countries hosting projects with us, or European-based organization, and American organizations. And you'll be able to recognize these names as they are really top technology companies in their domains. And these projects trust LFAI and data to host these projects. They trust us to help support these projects to grow and become de facto projects within their own categories. And of course, as an organization, we have the skills, we have the experience, and we have the support of our mother company or organization, the Linux Foundation, to help drive these projects forward, to grow them and enable their adoption and integration across the ecosystem. In addition to technical projects, we also have a number of initiatives that we support. We have one initiative dedicated to data ops. We have one initiative dedicated to business intelligence and AI. And also we have one committee or initiative that is focused on trusted and responsible AI. In addition to these 3 specific committees, we have also a committee that is active across the foundation that's called ML Workflow and Integration and Interop. And this committee is focused on creating integration opportunities. These are technical integrations across our hosted projects and between our hosted projects and projects in the ecosystem to enable that type of integration and close collaboration across all the players in the ecosystem. So we've had really an incredible momentum, especially in the past 24 months, despite all the different challenges in relation to the travel situation and whatnot. So today we stand at 51 member companies. We're hosting 35 projects, and we manage the IT infrastructure of these 35 projects. We manage their legal assets. We support their trademark efforts, legal compliance, etc. And our developer community is growing, and it is today north of 18,000 active developers in these 35 projects. That, in addition to the active communities we have with respect to the different committees I just mentioned in terms of data ops, trusted and responsible AI, BI and AI, and ML workflow. And what's really interesting is that we've been going with that momentum for 2 years, adding one new project to the foundation and one new member every month. So if you're listening to this talk and you're thinking to incubate your projects with LFA and data, I'm going to give you 8 reasons why you should consider us for hosting your project. We are a neutral host with open technical governance. Each of the technical projects hosted with us have their own technical governance. There is clear separation between the foundation itself and the governance of the projects. We have dedicated staff, whether it's myself as an ED or program managers or many of other staff focusing on the different type of support the project might need, from legal to events to marketing, etc. So this is actual staff that is available and eager to help enable the project and support it in different areas. We have the capabilities to provide training and certification program. We've already published training on edX as LFA and data, and we have the capabilities to leverage the Linux Foundation abilities in providing certification programs if this is something that is of interest to your projects. We also have an events team dedicated to support us in creating events as small as 50 people and as large as thousands of individuals. And now, especially with the openings of economies and travel and the gradual return to face-to-face events, we're really eager to get back to that and establish ourselves and our events as it used to be in 2018 and 2019. We have a developer-oriented operation focused on providing our developers in our projects with dedicated tool that will help them get insights about their projects via LFX, get security insights, and manage their projects the best possible way. We have the Technical Advisory Committee, which is the technical committee representing our membership, available to mentor the project and available to support you in many different possible ways. In addition to dedicated staff that will help in marketing and communication and PR services, ranging from announcing project collaboration to announcing new releases, supporting projects in events and demos, and many other specific situations. In addition to all of that, the last item I'm mentioning here is legal support that includes trademark registrations, compliance scans, CDO and CLI integrations, and many other items that would fall under legal support. In terms of governance, we are a 3-tiered foundation in that respect. We have the governance of the foundation itself, which constitutes the governing board, and within the governing board, there are a number of committees active in different areas. Then we have the technical leadership that falls under the Technical Advisory Council, and within the Technical Advisory Council, we have a number of initiatives and committees that I've already mentioned. And then we have the independently governed hosted projects. These are the 35 projects that I've mentioned earlier. So let's go back a little bit and talk about the ecosystem. So one of my favorite slides to show about the ecosystem is really the landscape that we've developed in LFA and data. And what's really interesting is that we launched the landscape in December of 2018, and we only had 80 projects listed on it. And today we have over 300 projects, 317 projects to be exact. And this is really a great way to learn about the ecosystem and how the ecosystem is really evolving. So 3 years ago, we started with 80 projects that we consider key projects in the ecosystem, and we more than tripled, almost quadrupled over the period of 3 years. And this is really incredible and a great indication of a very vibrant ecosystem. And these 317 projects that we see on the landscape today represent over 145 founding organizations and over 10 universities that created these projects and launched them as open source initiatives. So the collective efforts is over 450 million lines of code. And what's really fascinating is that the pace of innovation, the pace of development is almost 1 million new line of code every single week. And this is really just mind-boggling numbers. It's just incredible. And it's really hard to keep up at that pace. However, despite that growing ecosystem and really super active communities, there are some challenges. These challenges range from fragmentation across these different categories, lack of integration and lack of cross-pollination across these different projects. Some of the challenges are related to governance of the project. Some of the challenges are related to how these project assets are being managed. And all of these challenges together pose what we consider a glass ceiling for adoption and integration. So if you're an organization out there looking to adopt one of these projects, you ideally want a project hosted in a foundation that has a neutral governance. It has a neutral governance that is managing its assets, taking care of the trademark, taking care of all the project infrastructure, so that organization and developers focused on the project would dedicate completely their time to innovation and development rather than doing what we call typically plumbing, all the low-level action items that needs to be done to keep the project going. And what's really a pride for us and for me personally is that when we look at that whole ecosystem with about 320 core projects, we actually host over 10% of these projects in LFAI and data across multiple technology categories. And what you see on the screen is the landscape, but only featuring projects hosted in LFAI and data. And really our goal by next year is to have all these different categories where we don't have projects yet to be filled. So we will be able to offer companies and organizations looking to adopt projects in open source AI and data, a project in any given category within that ecosystem. Now, looking at our developer community. So what you see on the screen is really the statistics from 2020. And this is all great. However, what's really interesting is that we're growing year over year in terms of double digits increase from 2019 to 2020, and then from 2020 to 21. And you can actually review these detailed statistics from our LFX platform. The link is included in the slides. So you can see the commits growth. This is actual code being committed. It's been almost linearly increasing since 2019. Similarly, we have an increase in new contributors. So we're able to attract new contributors into our projects. In addition to that, we are able to increase the contributions by new committers. And this is great because it's not just existing contributors contributing and increasing their contributions, but we're increasing the number of new contributors coming into the project and also increasing the commits by new contributors. And today, we have over 380 organizations that are participating in code commits in projects hosted in LFAI and Data Foundation. And of course, this count does not include commits by specific individuals that are not being mapped directly one-to-one to a given organizations, meaning individuals signing up with their Gmail or, for instance, Hotmail account with no direct correlation with a given sponsor. And this is really an amazing number to have 380 organizations active in the 35 projects that we host in our organization. So we have a focused activity in terms of developer marketing. So what you see on the screen are specific activities and the related announcements focused on the projects and the developer community. And we're growing in terms of announcements, in terms of marketing and communication with respect to new projects joining, graduation of projects, integration of projects, adoption of projects, and also in terms of events. So the number of events is growing with us as we grow in terms of projects and as we proceed in the year. And we have really strong conference presence in all major events, in addition to our own events that for 2020 and 2021, we've had them as hybrid events and fingers crossed moving to physical face-to-face events in 2022. So this is all great. And what's really interesting are the challenges and trends we see stepping into 2022. So there are some really specific challenges there. Hiring talent is a challenge everybody can acknowledge with, as you know, and if you are a hiring manager, you've had real life experience with this. There's really shortage of talent in the space, and this is a challenge actually to come for the next few years. Computational power has always been a challenge, and every time we see increases or breakthroughs in terms of computational power, there's more data and there are more sophisticated algorithms that require additional computational power and so on. So this continues to be a challenge. Building trust in products and services that have AI infused in it is an ongoing challenge. Also in correlation with the bias problem, how are we able or how can we solve the bias problem and ensure trusted and responsible AI? Data privacy and everything in relation to data in terms of privacy, security, and data governance is an ongoing challenge. And of course, with all these challenges, there are opportunities that I will mention in the following slides. There are also challenges with respect to national policies and legislations. So many countries and whether you're in North America, in Asia, or in Europe, and for instance, in Europe, there are specific country legislation, and also there are legislation specific to the EU itself. All of these different challenges all of these different legislation poses different challenges on the development and the application of specific AI in specific usage model. And also there's the specific challenge of reaching human level intelligence, where there are some advocates calling for the danger of AI reaching that level and so on. And this continues kind of depending who you talk to, whether it's a challenge or it's a reality to happen. In terms of opportunities or trends, there are many opportunities posed by these different challenges. There are opportunities in terms of development and innovation in the trusted and responsible AI domain. Every day organizations gather additional data, and the amount or volume of data is growing exponentially. And the key challenge there is deriving value and insights from this data. So the opportunity is, how can we do this? AI and edge computing are getting close together. There's really a high priority, a need to make real-time decisions, and that's pushing AI closer to the edge. And there are, as you can witness in the market today, several organizations, a lot of startups, and really a lot of efforts going into that direction. In terms of hardware, there are a lot of specialization in terms of AI chip design. There are many opportunities there, both on the software and the silicon level, or the hardware level. Algorithms need to get more efficient and needs to get faster and smarter, and this is really an opportunity for improvements at many various levels. And one new domain, maybe in the past couple of years, has been federated learning, which is really a new way or a new approach to protect privacy while sharing data and training with sensitive user information. So although there are many challenges, all of these challenges pose different opportunities that we can use and innovate on and push forward in 2022 and beyond. Thank you for listening to my presentation today. I'm available on the LFA and Data Slack. You can reach me via email. And if you're interested to becoming a member of LFA and Data or incubate your projects with us, please follow us in one of these channels that you see on the screen, or directly send us a note to info@lfaidata.foundation. And thank you very much, and enjoy your conference.
Thank you, Ibrahim. Once again, thank you all for joining us here at the Open Source Summit Japan Automotive Linux Summit, and another big thanks to our sponsors and speakers. We hope you have enjoyed Keynotes and encourage you to join our breakout sessions beginning at 11 a.m. Japan Standard Time. Don't miss the live magic performance by Asia's Got Talent semi-finalist Takumi Takahashi at 12:50 p.m. Japan Standard Time today. We very much hope to see you in person next year, and enjoy the remainder of the conference. And finally, please have a wonderful day. Thank you so much, and bye-bye.